Okay, we are moving on to simplifying fractions today. Many of us think, hey, I can simplify a fraction. I've been doing it for a while. It's different because today I'm going to expand it with variables. So, you can simplify fractions with variables today. That's what you can do today. You need to know the vocab words expand, exponent, and simplify. Expand is to write out fully. You did that in your exponent lesson. Like 2 to the 4 is equal to 2 times 2 times 2 times 2. That's expand, writing it out fully. You also need to know that exponent is repeated multiplication. So I know that you feel confident about exponents. I can guarantee, I'm sure you feel confident with simplifying with numerical fractions. You divide a fraction through by the greatest common divisor. That just means the biggest thing that goes into both of them. All right, so I'm not going to do many numerical examples since you all have your own strategy for simplifying a numerical fraction. So when we're given an algebraic fraction such as x to the 4th y over xy, okay, and I'm going to tell you to simplify that today. Right now you might be like, have no idea what you want me to do. Well, just wait till you see. The first thing you do is expand out the variable if you have to. Like x to the 4th is how many x's? 4. So that's what I mean. Expand the variables that have to. Then you're going to cross out the common variables on the top and the bottom. For example, if I have 4 over 4, can't I just cross out those 4's?
Yeah.
And it just turns to 1, correct? So we're going to cross out common variables, and then we're going to rewrite with exponents. Okay, watch. A squared over a to the 5th. Step 1 says expand out the variables. So how many a's on top? 2 a's. So I'm going to write a times a over. How many a's on the bottom? 5 of them. 1, 2, 3, 4, 5. Now, cross out what you can. Share, share. What's left on top? It's not 0. What's left on top? 1. 1 has to come out. So I have 1 on the top. Now I rewrite 1 over a to the, how many a's left? Third power. That's it. That's how you do it. Next example, a squared b to the 5th c cubed over a squared b to the 7th c squared. Now it sure looks confusing, but I'm just going to follow my steps. Expand it out. So 2 a's, 5 b's, 1, 2, 3, 4, 5, 3 c's. All over 2 a's, 7 b's, 1, 2, 3, 4, 5, 6, 7, and 2 c's. Now is what I view as fun, crossing out the shared variables. Share the A, share the A, share B, 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 B. I don't share any more B's. Share C, C, and that's it. Now what do I have left on top?
C.
C over
B.
B to the how many? Second. Done. Okay, you try the next two. Okay, according to the steps now on this next one, I expand out my variables. So I have 3 x's, 1, 2, 3, 4 y's, 1, 2, 3, 4, all over 1x and 5 y's. 1, 2, 3, 4, 5. Cross out what I share 1x. I share 4 y's. It looks like 1, 2, 3, 4. I can't cross anything else out. So on top I have 2 x's left. All over what's left on the bottom is a y. Yeah. Okay, the next one. X squared y to the 6th over y cubed z to the 4th. 2 x's on top, 6 y's. Now notice I'm not putting a dot in between them, because when 2 variables stick together, it just means multiplication. 3 y's, 4 z's. Whoops, there I put a dot on accident. Okay, can I cross any x's off? No, because they don't share. I can cross 1, 2, 3 y's, and that's it. So on top I have 2 x's left, 3 y's, and on the bottom I have 4 z's. We're bumping it up one more level, and I'm throwing coefficients in front. Coefficients, again, are the numbers in front of the variables. So if I throw a coefficient in front, all you're going to do, well, what do I have here? I probably have expand the exponents and then simplify the coefficients. And that's like a normal fraction. You're just at the end dealing with your number parts. Okay. For example, 3x to the 4th over 9x, y squared, is equal to 3 and 4 x's over 9, 1x, 2 y's. I can cross out an x, simplify this into 1/3, and now I'm rewriting. So on the top I have x cubed. Now why didn't I put the 1 there? Do I have to put the 1 there? No. So I let the 1 hide if the 1 wants to hide. If the 1 does not have to show face, I let it just be in peace by itself. Over a 3 on the bottom and 2 y's. So do you see the difference there? Coefficients, you're doing the same strategy. You're just simplifying the coefficients as well at the end. Next one, 36. 2 a's, 4 b's over a 12, and 3 a's, 4 b's, and a c. Woo. Cross, 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 cross. What can I divide 36 and 12? What goes into both of them? Well, there's something bigger than 3 and 6.
12.
Sure, 12. So that's the GCD. Now, if you didn't notice, because not many of us noticed the 12 right away and you thought 6, sure. That would turn into 2 and 6. And then you should say, hey, 2 goes into both of those. 1/3. So what do I have left on top? Just a 3 over, what's on the bottom? A 1. Do I have to put my 1? No, so I'm going to let it hide. It looks like I have an A and a C. Alright, I went ahead and worked out the example above by expanding out, simplifying the coefficients, crossing out what they had in common, and I got that as my final answer. Now I'm going to deal with it with just numbers to a power where I don't have the x's or the y's or a variable. You still do it. You still expand it out. So how many 3's do I have on top on this next one? 4. So I have 1, 2, 3, 4 3's over how many 3's on the bottom? 2 3's on the bottom. Cross, cross. I'm left with what? 3 to the, which is 3 squared is 3 times 3? 9. Okay, so same strategy where you don't have to evaluate through. If they're the same base, which means the same big number, you can just expand it out and cross them out. Like 5 to the 6th. Have fun trying to do that. I don't even know what 5 to the 6th is. We're going to figure it out. 15,625. I don't want to do that. But I can go like this. I have 6 of them there. I have 3 of them on the bottom. I can cross out the common. I am left then with 3 of them. 5 times 5 is 25, times 5 is 125. And that's your learning target today, that you can simplify a fraction that has variables.